going to show you one example of an energy calculation without using a calculator. And you'll see that I rely heavily on scientific notation because I'm not good at working with big numbers, but I can work with small numbers. So we're going to look at a problem that is very similar to one of the problems in your packet, but a slight variation. All of the information up here is from one of the problems in your packet, only you're asked to calculate how much natural gas would be required to heat the house. And what I'm going to show you is the same thing, but looking at electricity, so kilowatt hours. The first thing you should do is figure out what information you need to know to solve this problem. So we need to calculate the number of kilowatt hours required to heat the house for the winter. So we know that 1 kilowatt hour of electricity supplies 10,000 BTUs of heat energy, so that will be important. We know that there are 100,000 BTUs of heat per square foot to heat the house for the winter, and we know the house has 4,000 square feet. We can, pretty much ignore everything about natural gas in this case. So when we set it up, we're going to start with what we know. So in this case, we know that the house is 4,000 square feet. So I'm going to write that as 4 times 10 to the third square feet. Like I said, I really like to use scientific notation. Avoid those big numbers. We want to cancel out square feet. We want to get how many BTUs per square foot. So we know that per square foot, we need 100,000 BTUs. So that's 1 times 10 to the fifth. Again, using those scientific notation. And now we can figure out how many kilowatt hours of electricity we need. We know that there are 10,000 BTUs of heat energy per kilowatt hour. So 1 kilowatt hour will get 1 times 10 to the fourth BTUs. So now, you can double check. Units cancel out. We'll end up with kilowatt hours, which is what we are trying to find right now. And now we're just going to use principles of scientific notation. So 4 times 1 divided by 1, well, that's still 4. And then with scientific notation, remember 3, and we're multiplying with 5, so we're going to add those, 8. And then over here, 10 to the fourth in the denominator, so 3 plus 5 is 8, minus 4 is 10 to the fourth kilowatt hours. Or if you don't like to leave answers in scientific notation, you would say 40,000 kilowatt hours. Now we want to know the cost of heating the house using electricity. So just like we see in a lot of free response questions on the AP exam, having to take information that you calculated in one part and use it in the second part. And remember, even if you got the wrong answer in the first part, if you set up everything and do your math correctly in the second part, you could still get full credit. So never give up. Always show all of your work. So we're going to use the cost right here. Now, one thing you'll notice about the cost, $50 per 500 kilowatt hours. I don't really like those numbers. I think we could simplify those. And 50 divided by 500, we could say it's $1 per 10 kilowatt hours. And that's going to be a much nicer number to work with. So we're going to use our information from the previous problem, which was 4 times 10 to the fourth kilowatt hours of electricity provided to heat the house for the winter. And we could say it's going to cost $1 for every, and I'm going to put it into scientific notation because I love it. So 10 is 1 times 10 to the first kilowatt hours. We're canceling out kilowatt hours. We're ending up with cost, right? Dollars. So all of our units check out. And then it's 4 times 10 to the third. This would be in dollars, or in other words, $4,000. So I use scientific notation pretty much for that entire thing, kept my math really simple, and always showed my units. If you do those two things, you'll be in a very good spot.